horrifying. When you spend 6 months working on your pilot house and then you got to start drilling holes in it, that's horrifying. Yeah.
Well, yes, I figured, but like, why do you drill the holes?
You got to screw stuff to it. Take out a sign at 7.1, please. On the passenger seat of my car is a Tupperware with baked potatoes and cheese and veggies, and I realize it's probably getting all the sun right now, and it's going to be disgusting if we don't get it in the fridge right away. Fridge would be good. Yep. Fridge. Oh, where's my car? Right down here. Silver Tacoma with lumber wrap. What? 7.2. 7.2, I lied. 7.2. Ha ha. Ha ha. Ha ha. Made you look. 7.2. Super mature, Jose. Yeah, we're going to do question number 22, and that's a biggie. Are you finding more column treasures? Did you see the Teletubbies one?
Yeah. That's
Hey, look, we're going to use this high-tech, cutting-edge technology of the 1970s today. First, I want to answer the question, what the hell is a dam to begin with? A wall where?
You put a wall in a canyon.
In a canyon. And it does what to the river?
Stops it.
Stops the river, creating a... Yeah, technically it's not a lake, it's a reservoir. When I am president, I will go to all the artificial lakes and I will rename them reservoirs. Because your impression of a lake is incorrect, because most of you have only experienced reservoirs, and lakes are distinctly different from reservoirs. And I have a chip on my shoulder about that. Yeah.
Because he can't be president.
Yeah, this is why I can't be president. Yeah.
Awesome.
The only reason. Yeah.
What's the difference between a lake and a reservoir that's so significant?
Well, lakes are natural, for starters. Reservoirs are man-made. Alright. How does that work? Once you've made the reservoir, what's in it for us?
And water.
You've named 2 of the 3 benefits. One of them is you can control the flow of water. Another one is you make electricity. But there's a third benefit that we rarely think about. Because in Santa Barbara, it's rarely a problem.
Recreation.
Yeah, the flooding is a big whoop. Recreational was an interesting bonus, but that's a very America thing. Like, that is so baby boomer. To think, hey, if we're going to spend a bunch of money, let's plan on making this recreational in traditional America ways, like boating and fishing and drinking on houseboats. That is so boomer. Globally, that's not a feature of reservoirs.
Really?
So, this is a weird symptom of our cultural privileges. Globally, the water supply, the electric, and the flood control are universal. In the US, we add recreation because we can.
There's this thing that says like US thinks of plan for the rest of the world to go carbon neutral. And it's like a picture
Yeah, I love that. But the crazy thing is, how the heck are you gonna build a wall when there's a river running through it?
Magic.
Just dig a like hole that like leads the river a different way.
Yeah, we have to dig a hole that moves the river a different way. David nailed it. Like this. You go to the side canyon wall. You're the river. There's the other canyon wall. You go to the side. Make a hole in the wall. And then I'm going to tunnel all the way through this wall. Like a gopher. Just pop on out. Up canyon of our construction site. And the water's still flowing, but I've got this cool little tunnel. And then we send some homies up on the side of the canyon, and they get bulldozers, and they start to push in rocks and sand. And you make like a temporary dirt pile, and then from that side too. And so all of a sudden there's like a speed bump. So now the river coming hits that speed bump and spills into the canyon. I blew my punchline. I said spills into I meant spills into the tunnel. I blew my punchline. Like that's your tunnel.
That's horrifying.
I know. And can you imagine like being stuck in there with the water and stuff?
Fun.
Yeah, that's what the horrifying part was.
Yeah. And well, it's also just scary because claustrophobia. Holes in the ground, and tunnels, and dynamite, and
It's a giant
canyons.
tunnel. Why would you get claustrophobic in it?
Caves.
I don't know, man. Being underground is always kind of awkward for me. I've been underground a few different times. Anyway, check it out. You can see where the water's kicking up on the speed bump in the background on the left image. You can see where there's a few little puddles. It's tough to see where the water is coming out of the tunnel. It's out of the frame right here. And so you've made like a dry building site. You can see the water going into the tunnel with an earthen dam deflecting the water. There's a backup tunnel if you lose this one. You can see the tunnels carved into the canyon wall in yellow. Where the original river bottom has those rippled ridge lines in this image. The newly created reservoir is watercolored. And the dam is shaped kind of like a contact lens to deflect the impact force outward to the canyon walls. So tunnels, move the water around, start piling up dirt and concrete, and oh my God, so much concrete. These are the largest construction projects. They're the biggest users of energy, the biggest users of concrete. The first record was broken by Hoover Dam in the 1930s. Then we broke that record in the 1940s. Most recently, China broke our record with the Three Gorges Dam. All the biggest things that humans have done were dams. There was a dam in the end of the Depression that did this, and then there have been 2 or 3 dams that broke each of those records. So the biggest things made by human are number 1 dam, number 2 previous dam, number 3 previous dam, number 4 earlier dam. Hey, you put your damn questions to yourself. I'm not your damn tour guide.
How many damn jokes did Jose make?
That was it, I'm done. Okay, a little bit of plumbing added to control the flow of the water. You build these overflows to take some water from the reservoir side. Silence. These will go through pipes out to the turbines. Those are the turbines. And then you close the tunnels and you capture that water. And holy crap, you have lifted the river. You can see what I mean by lifted the river. It's now 300 feet taller, right on the desert floor instead of the bottom of the canyon. Does that make sense to everybody? Desert floor, bottom of the canyon? Yeah? You can see that water coming out. That means that they are making electricity because it's coming out of the turbine jets. Like that. That water comes out really, really, really forcefully. Like unbelievable pressures. Like humans would just, like blowing dust off a box. Yeah.
I heard something that was probably false, but didn't someone like go through the Hoover Dam?
I would have to assume not, definitely not through that plumbing because there's turbines in the middle.
I mean, they could have, they just wouldn't come out in one piece.
Yeah, I mean, you could go in. I know that, like, those bypass tunnels are regularly serviced, and so once it's closed on the reservoir side, you could walk in from the down canyon side.
No, that's not what I just like, maybe it was something else. I just heard a rumor or something, someone like went through a dam.
Over it. When we built the first one, Hoover Dam, I'm going to move this slide. When we built this one, it took like 3.5 years to build the largest thing that had ever been built. We had humans in 8-hour shifts, 24/7, non-stop for 3.5 years. And it was at the end of the Great Depression, so people were so hard up for labor that there was basically a full-time, always there hiring line of people who would just camp out at the desert. And they were losing one American worker every 23.5 hours on average. To death, I mean, to accidents. And so they'd be like, oh, all right, you can come in. And they would basically just work through a workforce that was just waiting for jobs. But I want to remind you that this entire thing was built in 3.5 years. And I don't know if you've ever watched a project. Like my buddy Trent's been working on a boat for 3.5 years.
Or stadium.
The stadium! Bingo! I mean, like, I know people that have been working on a deck for 3 years.
Yourself.
No, I'm fast with decks. Point is, this was the first of its kind. This broke all records. People are like, huh, it works. And they're like, we got any other stuff to do? And they're like, it's a big ass river. And we went from no dams to the first dam to 10 others in a period of about 40 years. On that one river, the Colorado River has 11, but in those same 40 years, please look up, we built something like 147 on the Columbia River and something like 95 on the Klamath River. And like all major rivers have a dam in the entire nation. The last undammed river in California is the Sespe. There's one left without a dam. And technically, the Matilaha, I believe, spills into the Sespe and it has a dam. So you could argue that the Sespe has a dam on a tributary. We went crazy building dams. We built so many dams. And then by the 1970s, people were like, you know, this is kind of lame because we're like screwing up all the rivers. And so in the United States, we basically stopped. Kind of like that onion joke. All of our engineers that got really good at this were like, hey Brazil, do you want a dam? And Brazil's like, yeah, great, let's give me a dam. And so we just started building dams in other countries when we had decided we were over it here.
What's the onion joke?
That we're using solutions that we don't want for ourselves on other countries.
Oh,
Hey, remember that joke that you just told me about like 20 minutes ago?
I thought you meant like an
I'm gonna throw my keys. Stop it. I have more keys. Way more keys.
I have a Jetta.
Not scared. Of course you have a cheddar.
I see more of a super
Um,
Take one more.
so, I'd like you to prepare for this comparison. Remember how in study goal number 24, you did physical, ecological, and humans for rivers compared to canals? I'd like you to do physical, ecological, and humans for above the dam and below the dam. Like up canyon, down canyon. It'll be number 22. And hooray for us, we get to use this exciting new technology called overhead projectors.
What about 23? Are we gonna take any notes on that?
A little bit. I'd like to tell you where we're going first, so you probably don't need to copy, but I would like you to see something first. Please look up. When a river is wild, it has seasons. That should be a no-duh statement. Seasons are different depending on elevation. Like in snow country, rivers are solid in the winter. They flood in the spring snowmelt. In summer they run pretty heavy but clear, and then in the fall they usually run dry before the winter snow makes them solid again. That's high elevation. In low elevations, your seasons are usually a little bit more like ours, where maximum flow is in the late fall, early winter, and then things kind of peter out and dry out as soon as the rain stops in low elevation, like ours. But the basic idea is that rivers have seasons. Either in the summer or the fall they go dry. Either in the winter or the spring they get really wet. Remember also that fast-moving water carries stuff. So there's like a sediment season, where sediment is swept away in heavy water and settles in light water. So here's the Peruvian high elevation Amazon. Here's the Yangtze, I believe. I don't know how to say this right, in China.
That's right.
And you can see that those rivers have like a distinct wild character in different seasons, but the whole point of a dam is to flip that upside down. You don't have to copy this, but one thing you may want to write is that the whole point of a dam is to reverse the seasons. Like nobody wants water when it's raining. So you can keep the dam shut and store water when it's raining. Dams stock up water in the rain instead of being full of water downriver. And then dams release that water in the dry season when there wouldn't be water there naturally. That's why we do dams. The whole logical purpose of a dam, the argument for a dam, is to flip the seasons. Hey, there's water everywhere. I don't need any more. Hold it. And hey, you guys, there's no water around. Let's let some water out. That's the exact opposite of what would happen naturally. Dams are there to reverse the seasons. And as it turns out, because they're deep, they get cold. Because they stop water, they capture all the sediment. They end up changing everything about a river. Like this. Above the dam, uphill of the dam, they flood a canyon. So areas that used to be dry are now underwater. They also evaporate a bunch of their water I'd like you to add notes more than what I wrote on that screen up there. Please look up over my head. Up here. Up here. Can you imagine how there's more sunlight and more wind in that than there would be in this? Right? More sunlight because you're above the canyon's shade, and more wind because you're at desert level, right? Reservoirs evaporate up to half their water. More sunlight, more wind when you lift the river. Does that make sense? When you lift the river up to the desert floor? Like if it's in the canyon, you could be walking across the desert and you don't know that there's water. It's way down there, 200, 300 feet down. There's like a little ribbon of water that's sheltered from the wind. It's sheltered from most of the sunlight. So you don't get a lot of evaporation down there. But when you bring the water to the surface, now you're losing a lot of water, up to half their volume. Yeah. And of course, because they slow down the water, all the sediment load falls out of the water. This is just like the grit chamber in the wastewater treatment plant, where you slow the water, the solid stuff will settle. Because fast-moving water can move all sorts of stuff, but slow-moving water does not. The downhill problems are basically the opposite of what I just said. They're the complement to what I just said. So if you lose half the water, you've got double the salt. Does that make sense to everybody? How salinization is based on evaporation? If you lose half the water, the same amount of salt has to fit into the remaining half the water, so you've got double the salinity. You've doubled your units of salt per gallon.
But wouldn't there be less salt because there'd be more water?
Okay, so remember that the salt does not evaporate, and the water has left. It's like students per classroom, right? If I had the same number of students, but I got rid of half the desks, those kids would be double the concentration. There'd be 2 kids per desk now. Yeah, I know. Ask me, what? You don't look convinced. Say it.
Wait, so but doesn't the water evaporates uphill, so downhill does it still evaporate? Or?
Okay, I got you. This water's moving, so it goes through an area where water is lost, but salt isn't. When that water keeps moving downhill, you've packed the same amount of salt into less water.
Oh, okay.
So now the remaining river has been salinated by evaporation along the route. Yeah? Does everybody understand why the water gets cold? That's really effing deep right there. That's 300 foot deep. That's so deep that you start to get like shaded cold water, like the way that you swim down in a pool, you can tell it gets colder. Or if you free dive, you like get the 10 degree hit, sorry, the 10 foot hit and then the 30 foot hit. And you know, sediment to us is just sand and water, but ecologically that sediment is going to be really useful later. So I want you to remember that below a canyon you have less sediment and water. So this is going to cause ecological changes. Uphill, you fragmented the habitat. You know what I mean by fragmenting? You make it into pieces, it's not continuous anymore. Hey kids, there are 2 barriers in the photo on the left on the screen. There are 2 barriers. Could anybody tell me what the 2 of them are? What's one?
Well, one of them's the dam.
The dam itself, because that's a barrier within the river. What's the second barrier?
The water is separated into 2 sides of the canyon.
That's right. If it's like a little creek A rabbit can swim and get swept away a little bit, or it can find a couple rocks to jump, or it can go across a tree. If it's a river, most wildlife can cross that river. But that reservoir is like 3 miles across in some places. No rabbit is swimming across no 3-mile reservoir. And so what's interesting is there are 2 fragmented habitats. The river's been divided and the land has been divided. People have found genetic isolation in lizards, birds, rabbits, mice, what are the kangaroo rats? Where you add the reservoir, they basically just become 2 separate populations. It's just like building a big wall.
Wouldn't the canyon kind of be the natural barrier anyway, then?
You're totally right in the sense that some stuff can't get across anyhow. But you know, all you need is a few to bleed genetics, right? So like some random mouse gets swept away on a branch and lands on the other side. Lucky mouse, irrelevant to us, but that's genetic continuity. There is no way you're getting swept across that freaking reservoir. Now the downhill stuff, this is the big list. For example, if a fish is evolved to live in muddy water, imagine how it's going to stand out in clear water. And this is a big thing in the Colorado River. There's a type of fish which only travels up and down the river during like floodwaters, and now all the sediment is captured, so the floodwaters are clear, and you can document this, that osprey are eating better, and the Colorado River bottom sucker fish, or whatever it's called, mud sucker, it's got some wacky name because it eats mud. That fish is going extinct because they're designed to swim slowly in mud water, and in clear water they just get picked out by birds that eat fish. Remember that when you lose the mud, that used to be habitat. That mud is where some bugs laid their eggs. That mud is where those mud suckers ate stuff out of the sand. That mud is where the decomposers were, where the nutrient cycling happened. Like I said, the temperature has changed. Sediment is where plants grow. And making the water saltier is a problem. Children, what's the famous water problem that's not here? There's one famous problem with dams. It's the problem that usually wealthier white people complain about, and Native Americans.
There's no water downriver? Everything upriver is flooded?
Pacific Northwest. There's something that can't make it up the dam.